The Moon is Earth's only permanent natural satellite. Lunar missions are essential for several significant reasons. The Moon holds valuable scientific information about the early history of our solar system and the processes that shaped Earth and other celestial bodies. Lunar missions aim to identify and understand potential resources present on the Moon, such as water, ice. Lunar mission drive technological advancements, developing and testing advanced robotics, landing systems, communication technologies, and life support systems for lunar missions can lead to innovations that have applications in various industries on Earth. Understanding how to live and work on the Moon is vital for preparing for future crewed missions to Mars and other distant destinations in the solar system. Lunar missions often involve international collaboration. Studying the Moon can also provide insights into Earth's history and environment. Lunar missions capture the imagination and inspire the next generation of scientists, engineers, and space enthusiasts. The name Chandrayaan is derived from two Sanskrit words, Chandra and Yaan. Chandra means moon and Yaan translates to vehicle or craft. Therefore, Chandrayaan can be understood as moon craft or moon vehicle. The name reflects the primary objective of the mission, which is to explore and study the Moon. Chandrayaan-1, India's first mission to Moon, was launched successfully on October 22, 2008 from Satish Dhawan Space Center in Sriharikota. The mission included a lunar orbiter and a spacecraft. India launched the spacecraft using a PSLV-XL rocket serial number C11. The mission was a major boost to India's space program as India researched and developed its own technology in order to explore the Moon. The vehicle was successfully inserted into lunar orbit on 8 November 2008. The primary mission objectives of Chandrayaan-1 were as follows: to create a detailed 3D maps of the lunar terrain and study the mineralogy and the chemical composition. It was intended to search for water ice in the polar regions. The spacecraft carries 11 scientific instruments or payloads built in India, USA, Germany, Sweden, and Bulgaria. The 5 ISRO payloads which the mission carried are terrain mapping camera, hyperspectral imager, lunar laser ranging instrument, high energy X-ray spectrometer, and moon impact probe. The 6 payloads from the other space organizers are Chandrayaan-1 X-ray spectrometer, near-infrared spectrometer, sub-kilowatt atom reflecting analyzer, miniature synthetic aperture radar, moon mineralogy mapper, and radiation dose monitor. These payloads provided valuable data and insights about the Moon's surface, geology, mineralogy, and atmosphere, contributing to our understanding of Earth's natural satellite. Among its many achievements, the greatest achievement was the discovery of the widespread presence of water molecules in the lunar soil. This finding revolutionized our understanding of Moon's geology and potential for future human exploration. The Moon Impact Probe crash-landed on the lunar surface on 14th November 2008. The Moon Impact Probe was one of the 11 scientific payloads on board Chandrayaan-1. Following the successful deployment of the Moon Impact Probe, the other scientific instruments was turned on, starting the next phase of the mission. The spacecraft communicated with the Earth through Indian Deep Space Network (IDSN). On August 29, 2009, the communication with Chandrayaan 1 was lost. The American Institute of Aeronautics and Aeronautics has selected ISRO's Chandrayaan 1 contributions to space science and technology. The International Lunar Exploration Working Group awarded the Chandrayaan 1 team the International Cooperation Award in 2008. US-based National Space Society awarded ISRO the 2009 Space Pioneer Award in the Science and Engineering category for the Chandrayaan 1 mission. India's second lunar mission, Chandrayaan 2. Chandrayaan 2 mission aimed to advance our knowledge of the moon, improve our understanding of lunar processes, and lay the groundwork for future lunar exploration. Chandrayaan 2 mission was successfully launched on 22nd July 2019 by GSLV Mk3M1 from Satish Dhawan Space Center, Sriharikota. The main objectives of Chandrayaan 2 were to study the moon's surface and its mineralogy using a remote sensing orbiter. The orbiter was equipped with various scientific instruments to capture high-resolution images and collect data about lunar terrain. To achieve a soft landing on the lunar surface near the South Pole region. Exploring the South Pole region of the moon was a strategic choice for the Chandrayaan 2 mission due to several scientific and practical reasons. Scientists believed that lunar South Pole region could potentially hold significant water ice deposits. Water is a critical resource for future human exploration and can also provide insights into the moon's history and evolution. Exploring this region could provide valuable information about the moon's geological history and shed light on its early information and evolution. Vikram lander and Pragyan rover were the two key components of Chandrayaan 2 mission to the moon. The Vikram lander was designed to be the spacecraft that carried the mission's rover Pragyan to the lunar surface. It was named after Dr. Vikram S. Sarabhai, the father of Indian space program. Pragyan, meaning wisdom in Sanskrit, was a robotic rover carried by the Vikram lander. The spacecraft entered lunar orbit on August 20, 2019. On September 7, 2019, Vikram lander separated from the orbiter and began its descent towards the lunar surface. During the final stages of the descent, communication with lander was lost. As a result, the Pragyan rover was not employed and the scientific experiments planned for the lunar surface were not carried out. Although the mission's lander did not achieve a successful soft landing, the orbiter continues to be operational and contributes valuable data to lunar science.
Chandrayaan 3 is a follow-up mission to Chandrayaan 2, which was India's first attempt to land a spacecraft on the moon. The scientists behind Chandrayaan 3 were determined to learn from the mistakes of Chandrayaan 2 and make their mission a success. They designed a new spacecraft with better landing systems and more advanced instruments. One of the most exciting things about Chandrayaan 3 is that it will carry a new generation of cameras that can take pictures of the moon's surface in incredible detail. These pictures will help scientists learn more about the moon's geology and history. Chandrayaan 3 is a fantastic example of human curiosity and the spirit of exploration. It is a mission that will help us to better understand our nearest neighbor in space. This is the first time that India will attempt to land a lander and rover on the moon. the lander will soft land on the moon and the rover will drive around and collect samples. The scientists will then study the samples to learn more about moon's history and geology. The Chandrayaan-3 mission will also conduct a number of scientific experiments on the moon. These experiments will study the moon's surface, its atmosphere, and its interior. The scientists hope that these experiments will help us to better understand the moon and its origins. It will also develop and demonstrate new technologies that can be used for further space explorations. These technologies include the lander's soft landing system, the rover's mobility system, and the scientific instruments that will be used to study the moon. The main components of Chandrayaan-3 are the rover, the lander module, and the propulsion unit. The rover is a small car that will explore the moon. It has tools to collect samples and take pictures. The lander module is like the house for the rover. It will carry the rover to the moon and then let it go. It also has a way to send data and pictures back to Earth. The propulsion unit is like the engine of the rocket. It helps the rocket travel to the moon. The lander module of Chandrayaan-3 is called Vikram, which means victory in Sanskrit. It is named after Vikram Sarabhai, the father of the Indian space program. The lander is designed to soft land on the moon and to deploy the Pragyan rover. It is also equipped with a variety of instruments including cameras, spectrometers, and a magnetometer. These instruments will allow Vikram to study the moon's surface, its atmosphere, and its magnetic field. The different tests conducted on the lander are integrated cold test. This is the test that is done to check the performance of the lander system in a cold environment. The lander is placed in a chamber that is cooled to a very low temperature, and the systems are then activated to see how they perform. This test helps to ensure that the lander will be able to function properly in the cold environment of the moon. Integrated hot test. This is a test that is done to check the performance of the lander system in a hot environment. The lander is placed in a chamber that is heated to a very high temperature, and the systems are then activated to see how they perform. This test helps to ensure that the lander will be able to withstand the heat of the moon's surface. Lander leg mechanism. This is the mechanism that allows the lander to land safely on the moon. The lander legs are made of a strong material that can withstand the impact of landing. The legs also have sensors that allow the lander to adjust its position as it lands, ensuring that it lands safely. The rover used in Chandrayaan-3 is called Pragyan, which means wisdom in Sanskrit. It is a small, six-wheeled vehicle that is about the size of a microwave oven. Pragyan is equipped with a variety of instruments including cameras, spectrometers, and a drill. These instruments will allow Pragyan to study the moon's surface, its atmosphere, and its interior. Pragyan is also equipped with a mobility system that allows it to move around on the moon's surface. The mobility system includes 6 wheels that are powered by electric motors. The wheels are also equipped with sensors that allow Pragyan to avoid obstacles and to navigate on uneven terrain. Pragyan is expected to operate for up to 14 Earth days on the moon. During this time, it will travel up to 500 meters and collect data on the moon's surface. The data collected by Pragyan will help scientists to better understand the moon's history and geology. The key technologies used in Chandrayaan-3 are altimeter. This measures how far Chandrayaan-3 is from the moon's surface. This helps the spacecraft land safely on the moon. Velocimeter. This is a tool that measures how fast an object is moving. They use laser Doppler velocimeter in Chandrayaan-3. Inertial measurement unit. This tells Chandrayaan-3 which way it's going and how fast it's moving. This helps the spacecraft navigate through space. Propulsion system. This is the rocket engine that helps Chandrayaan-3 travel from the Earth to the moon. navigation and guidance control. This system tells Chandrayaan 3 where to go and how to get there. It's like a human's brain that helps us make decisions. Hazard detection and avoidance. This system helps Chandrayaan 3 identify any obstacles or dangers on the moon's surface like rocks or craters and avoid them to stay safe. Propulsion unit. This is a spacecraft's energy source. It provides the power that the other systems need to work. Chandrayaan 3 was launched from Satish Dhawan Space Center, Sriharikota on July 14, 2023. It entered a lunar transfer orbit on July 15, 2023. The lander is expected to land on the lunar South Pole region on August 23rd or August 24th, 2023. Before we conclude, let us go through some common terms that you should know. Escape velocity. Escape velocity is the minimum speed needed to escape the gravitational pull of a celestial body. For the moon, the escape velocity is about 2.38 km per second. This means that a spacecraft needs to travel at least 2.38 km per second in order to break free from the moon's gravity and continue on its journey into space. Lunar orbit. Lunar orbit is the path that a spacecraft takes around the moon. In order to achieve lunar orbit, a spacecraft must slow down its speed so that it falls into a stable orbit around the moon. This is typically done by firing the spacecraft's engine at the appropriate time and angle. Separation from rocket. Separation from rocket is the process of detaching a spacecraft from the launch vehicle that carried it into space. This is a critical operation as it ensures that the spacecraft is released at the correct trajectory and speed to continue its journey towards the moon. Chandrayaan 3's journey is like a thrilling adventure. Its launch is the exciting start of the mission, and its landing is the triumphant moment of reaching the destination. We eagerly await updates on its progress. As Chandrayaan 3 continues its journey, let us remember that space exploration is a grand quest for knowledge and discovery. It inspires us to dream big, learn more about the universe, and strive for greater heights. Chandrayaan 3 exemplifies the spirit of exploration, pushing the boundaries of human achievement and igniting our curiosity about the vast cosmos. Thank you.